Now, analytics software such as Spotfire, Power BI, and Tableau have a wonderful ability to perform complex multivariate analyses, and they've really become the tools of choice to understand what drives hydrocarbon production in the subsurface. But we know that every customer and basin is different, and what works in one set of circumstances is unlikely to work in a different set of circumstances. Unlike some of our competitors, our goal here isn't to do the analyses for you. Our goal is to make the data stored in your GeoGraphix projects accessible in the analytics tool of your choice, so you can perform the analysis that makes sense for you. Now, we've always had a powerful relational database for data storage in GeoGraphix. So it's always been possible to access GeoGraphix data in Spotfire, Power BI, Tableau, any number of those tools. And many of our customers do just that. But doing so requires an understanding of the underlying GeoGraphix data model, and that's not easy. Now the trick here is to get GeoGraphix data into Spotfire in a form that Spotfire understands. And really, what Spotfire understands is spreadsheets. Works best on spreadsheet data. In our latest release, 2023.1, we solved the problem with a single button click from Zone Manager. Now you can think of Zone Manager as almost a Swiss Army knife for viewing and editing subsurface data in a spreadsheet format. Wells on the left, attributes associated with the zone as columns. Really, it's the integration point in GeoGraphix where a lot of data calculated from GeoGraphix map grids or your user-defined petrophysical equations or variables that are being calculated such as lateral length or gas, oil, BOE per foot of lateral. This is where it's stored. And we've added a new feature in 2023.1 that lets you create a database view from a Zone Manager spreadsheet and have that spreadsheet instantly accessible in Spotfire. But first, let's take a look at Zone Manager. Zone Manager is a very flexible tool for storing attributes associated with subsurface zones. And as I pointed out, there are several different ways in GeoGraphix to create zone attributes. So let's look at a few. For well data, I'll use the zone scan calculator. And what the zone scan calculator does is it lets you extract zone attributes from vendor and proprietary well data. So if I wanted to calculate the sum of perfs over a subsurface zone for every well in the project, I can certainly do that. I'll go ahead and sum up my perf intervals for my active zone, the Niobrara, associate that with an existing attribute, and maybe apply a well-based filter. Alternately, if I want to calculate the average bottom hole hydrostatic pressure for all my DSTs for my active zone on a well-by-well basis, again, it's easy to do using Zone Manager, and I'll just show you how to do that right now. There's my hydrostatic end pressure. I'll extract that. I'll take the average of that, extract it over the Niobrara zone, associated with an existing attribute in the database, and maybe apply a well-based filter. New in Release 2023 are tools for calculating key production metrics from production data, such as 60 or 180 day BOE per foot of lateral in the well. This tool can be accessed from the Tools menu and fairly easy to use. You just select the number of months production that you want. I'll select 6 months, that's 180 days. The well inclination, this is the inclination at which the well goes horizontal, and the lateral length is calculated from that point to the bottom hole. The producing zone, in my case, I'm going to choose our Niobrara formation. And the statistic that you want to calculate. First N months BOE per foot of lateral. You select the zone, which is our active zone, and the zone attribute that you want to save the information, the calculated information to, and I'll just choose that one. Go ahead, and we can calculate that information very quickly. We'll do that for 2,472 wells. We've also added a tool for calculating wellbore parameters, such as lateral length, perfed lateral length, TVD at landing, and whether or not the well is toe up or toe down. Again, the tool is accessible from the Tools menu, Compute Survey Metrics, and you have 6 metrics that you can select. Let's go ahead and just say lateral length by perfs. So this is only the perfed lateral length. And we'll select our Niobrara zone and the attribute that you want to save the data to. Niobrara lateral length by perfs. Again, go ahead, calculate that, and then you can add it to your spreadsheet. Attributes can also be calculated from grid layers. In this case, I want to extract porosity for wells in my area of interest from an isomap grid. You can access the tool from the Import menu and then select the grid, the zone, the attribute name, and the filter. Click OK, and those attributes, the porosity, will be extracted as an attribute for all the wells in the area. Moving to a different application, in this case GVERSE Petrophysics, let me show you how to extract zone attributes from curved data statistics. Now, after generating a curved data statistic, the resultant calculations can be saved to Zone Manager. Again, pretty easy. Select your zone, Niobrara, and the attribute that you want to save the extracted information to. And then you go ahead and save it. And now it's in your spreadsheet in Zone Manager. If a geomodel is active in GeoPlus, the percentage length of DSTs, cores, perfs, completions, and IPs in a zone can be extracted and saved as attributes. Zone Manager also has robust tools for importing proprietary data or data from third-party applications in the form of CSV files. So, why are we spending so much time talking about Zone Manager when this is a webinar on analytics? Well, that's because calculated rock properties and detailed well information are precisely the interpretive data Spotfire needs for analysis. We must enable access to the zone data we're generating in GeoGraphix in our analytics software to be successful. So, how do we do it? Well, in the 2023 release of GeoGraphix, it's easy. Simply save your Zone Manager spreadsheet as a database view inside the GeoGraphix database. Then the contents of that spreadsheet are instantly accessible in Spotfire, Power BI, Tableau, or any other analytics software. Now here's where the magic happens. From the Import menu, choose Create Spotfire Power BI Views. Create the view. I'll just name it Webinar 1. Select OK. And it'll go ahead, create the view, calculate your position data, and the contents of this spreadsheet will be in that view. And that's really it. There's no bells, no whistles, no bands playing. You don't need to understand the complexity of the underlying data model or perform complex data joins for multiple database tables in the Spotfire application. It's just a few button clicks and you have all the GeoGraphix data you need for an analytics workflow. Now you can think of a database view as simply an Excel spreadsheet. In Spotfire, these spreadsheets or database views can be linked to a Spotfire visualization from the underlying data source. In our case, the underlying data source is your GeoGraphix database. Now we can link our Zone Manager spreadsheet to Spotfire and create a new Spotfire visualization. From Wellbase, navigate to the Analytics menu, select New, and create a new Spotfire visualization using a template. I'll just name it Webinar 1 and open the visualization. Once we've opened the visualization, we can link to the data. Now, all analytics software have robust capabilities for linking to third-party data, and Spotfire is no exception. So, I'll go here in File, hit the little plus, and use ODBC, which is Open Database Connectivity, to connect to the spreadsheet view I just created. You always want to select GXDB. GXDB is the data source name for GeoGraphix data. Hit OK, and then select the view. Now this is the entire data schema in your GeoGraphix project. It's pretty extensive, as you can see, but we don't need to worry about that. All we need to do is select our Webinar 1 view, give it a name. I'll just name it Webinar 1. Select OK, and link to the data. Now remember, this data is linked to GeoGraphix. It hasn't been imported. It's live on the underlying data store inside of Spotfire. We'll look at our data table properties, make sure that it's there, and we can see, yes, that it is there. There's also a wellheader view that gets created or linked when the template is created, your visualization is created. We don't need that anymore because all of your Scout ticket data is already included in the Spotfire view that you created in Zone Manager. So I'll go ahead and delete that. Now let's take a look at the data. And the easiest way to do that, at least I think so, is to create a visualization from it. And in this case, just add a table. Now if we take a look at our Zone Manager data, you can see that that is an exact copy of the data that we have in Spotfire. And it's actually live on the data. So let me do something just to prove that. We'll look at the lateral length here. Okay, so we have Niobrara lateral length for this particular well is 10,000. Oops, let me do that again. Is 10,875 feet. We'll sort here. We can see that that lateral length is 10,875 feet. I'm going to change that to 20,000 feet. Save it. And update. Relink the data. The lateral length for that well has been changed to 20,000 feet. This just shows you that you're live on the underlying data. When you add or edit attribute data inside of GeoGraphix, it's automatically linked to Spotfire. You don't have to re-import or rebuild a view, do anything like that. It's there and it's there for you. I'm no Spotfire expert, but I managed to build a small Spotfire visualization using the zone attribute data linked from Zone Manager. I'll open up the visualization in Wellbase. This visualization analyzes barrel of oil equivalent per foot of lateral versus total lateral length of wells producing from the Niobrara Formation in the DJ Basin in eastern Colorado. Now I've set up a couple terraced views to compare production per foot of lateral from the 10 or so largest operators in the years from 2012 to about 2016. None of these companies are still operating independently, so I won't be making any shareholders angry when I say that Bayswater Exploration had the lowest oil production per foot in wells with 0 to 5,000 feet of lateral length, and Kerr-McGee had the highest. But notice the 20,000 foot outlier in the data. I'm interested in that outlier, so I'll mark the well and I'll send it to Wellbase. Okay, so it is a Kerr-McGee well, and let's change that 20,000 foot lateral length back to 10,850 feet, which it should be. So I'm going to go ahead and change that right here. 850. Save it. And when I relink in Spotfire, you can see my application, my visualization updates automatically. Now I've also built a model in Spotfire that uses multivariate analysis to come up with a goodness coefficient. It's basically a value that predicts your best wells based on the data that you've input into Spotfire. Now after generating the coefficients, I'll use the Spotfire plugin to add them back to my project as a Niobrara attribute. So I'll go ahead and select some of those wells to mark them. I'll add a zone attribute. I'll pick my attribute. And let's see what I got here. Model coefficient. My statistics, I'll just say it's the max. And I will overwrite the existing values in Zone Manager. Once I do that, going back to Zone Manager, I'll update. And where are those model coefficients? Right there for those wells. Well, that's all we have for today, folks. I hope you found this webinar interesting and informative. In GeoGraphix 2023, we really have taken the complexity out of using GeoGraphix data with your analytics software.